Hi everyone, thank you for coming. So this talk is going to be really for the people who are not that familiar with Vue. This is going to be very high level and just introducing Vue to those who've probably only briefly looked at it. So if you've used Vue in production or already know all this stuff, like just wait for the more interesting talks after it. But so let's begin. So myself, my name is Evan Yu, and this setup is a little weird. So that's my Twitter handle, that's my GitHub handle. Both are different. In the past, I worked at Meteor and Google Creative Lab, and now I'm just working on Vue full-time, doing open source as my job, which is great. Actually, shameless plug here, we have a Patreon campaign, which is my main source of income. So if your company uses Vue and look at the Patreon campaign, consider sponsoring, and you'll get your logo up at our website, which has a ton of traffic. So Vue started back in 2013. The very first commit was in July 27th, 2013. But this was the first commit of a prototype experiment, which was really just a on-the-whim attempt to write a little Angular, sort of. I was at Google back then, and we used Angular for a bunch of projects. And there are parts of Angular I really liked. There are parts of it not so much. And what I wanted to do initially was to extract the good parts that I liked about it into this easier to digest format, so that I can use it in some of the projects I was working on. Because I was working on a lot of really small, fast prototypes that really requires this fast turnaround, and I didn't really want to bother with all these huge concepts that have to be thrown in when you're using Angular. So that was the original idea, and it started as a prototype, right? So it remained a prototype for maybe half a year, and the first public release was in February 2014. So that's like almost half a year later. I posted to Hacker News. I don't know why I don't have the slides here anymore. But I posted to Hacker News, it got voted to the front page, and stayed there for a few hours, which was good enough. I got like 600 stars in that week. That was like, yeah, that was like so good for me back then. And then working on it a bit more, because more and more people started using it. Just so you know, it remained a side project all the way through my time at Meteor. We had discussions in Meteor whether how we can integrate Vue and Meteor in an official way, but it didn't really work out that well due to the resources that Meteor as a startup has to prioritize on. So it remained a side project, and during that time I still kind of worked on it in my spare time, and we released more 0.x versions until October of 2015. I actually took like 3 weeks off to push for 1.0. Of Vue. And after that, so after 1.0, things really started to pick up. And also in that process, it was discovered by the Laravel community, which kind of kicked up, was a good, really big adoption from the community of Laravel. So after that, I started to think, hey, like Vue is growing really well, and if there is a way I can, make it a full-time job, make it somewhat financially sustainable, then this would be like the best job ever. So I set out to do it. I started a Patreon campaign, and I quit when I was at like $4,000 a month or something. And now it's growing well enough, combined with other sources of income. I think I make more money than I was at Google, so it's pretty good. So in October last year, we released 2.0, which is a complete rewrite from the ground up. So that rewrite introduced a lot of we took a lot of good ideas from the other frameworks in the process. We rewrote the rendering layer with the virtual DOM, and we also had a lot of interesting concepts, which we'll talk about later. But today, Vue. So this is the stats from this morning. We have like 64,000 stars on GitHub. I think we're like currently 8th most starred projects of all. And we'll soon pass Awesome to become the 7th most starred. 662,000 monthly NPM downloads. Just so you know, we have a lot of downloads from the mirrors in China. Vue's adoption in China is probably even bigger than in the Western world. And this one is the most stats I kind of take most seriously, because this is the Chrome DevTools extension, and it's a weekly active users. So it's more reflective of the users who are actually using Vue non-trivially. They've actually installed the DevTools so that they can actually build an app. And we're seeing more and more commercial usage around the world, and some of you probably are already hiring Vue developers, which is awesome. And the community is also growing. So we have over 300 GitHub contributors across the anti-Vue.js organization. This covers all like umbrella. So it covers all the satellite projects under the Vue.js organization, like our build tool chains and router or Vuex and all that. And we have a team of almost 20 people. And we have great community members contributing all the tooling and stuff. Pine is actually here today going to talk about his awesome VSCode plugin. And we have these thriving community projects like Nuxt, which is a server-side rendering framework similar to Next.js for React. Quiza is essentially an Ionic for Vue. Element UI, iView, and the rest are all like sort of UI component collections, or like material UI in that sense. And yeah, so all of these have like several thousand stars on GitHub. So obviously a lot of people actually use them. Evolution. So the way that Vue is, so today I call Vue something called a progressive framework. But in the beginning, it really was just a Vue layer library, similar to what React stands. And the idea of just a Vue layer library is that you can and you have to pick and choose all the additional parts to eventually build up your own stack, front-end stack, in order to actually build a real app. Sorry. But over the progress, I start to think about like, where does Vue actually fit into this whole picture of front-end frameworks? Because that then, when I first started working full-time on Vue, it was like, I was pretty stressed out because React is growing really, really huge, and Angular 2 is coming out. So I was thinking, like, what differentiates Vue from these? They're backed by big companies. They have big teams. Like, how do we differentiate from them? And the idea is something called the progressive framework. And the idea is that we will have this lean, like Vue layer only core, but we'll also have these additional satellite projects like an official router and official state management library, official Webpack loader, official build tool chain, CLI, and all that stuff. We'll have all of these, but we don't make them the required parts. They're opt-in. So this gives us something that can be incrementally adopted depending on your use case, right? The thing that we loved about the web, and I loved about the web when I first started learning coding, was the fact that you can just open an HTML page and drop a script tag in, and you can instantly start doing things and seeing them on screen, which is really nice for prototypes, and which is also really important to allow people to start learning. So that's a tenet that I really want to preserve when I'm working on Vue. And although I see the necessity of these complicated tooling when you're building modern, huge single-page applications, I still think it's great that if you can still somewhat preserve this simple to use, easy to onboard nature of web development, that would be a great plus for me. So this is what the progressive framework is all about. I want to have this core that can be dropped in anywhere. And I also want to have these additional parts that are officially supported. They're designed to work together, but you are not required to use them. But if you do want to have a whole stack that's built together, designed together, then it's there for you, and you can just use it all. So that's the whole idea. I think I've already talked through a lot of the slides after that. But the idea came when I was thinking about application complexity versus the framework complexity. Like a lot of, I see people complain about like front-end tooling is becoming more and more complicated, so many new things to learn and all that. And I'm just wondering, like, right, when we discuss these problems, in the end, we're just like, these concepts are invented to solve problems because the problems we're trying to solve are hard, so we come up with these additional technologies to try to make it easier, right? And it would only make sense if the intrinsic problem you're trying to solve is hard. If the problem you're trying to solve is easy, then why do you even bother with these complicated stuff? So, and when we think about web development is very, very diverse. Some people work on really simple web stuff, little widgets or just a static page with some little interactive bits. Some people work on extremely complicated single-page applications like Gmail, stuff like that. Right? So the spectrum of the type of apps we're building on the web is extremely diverse. And it's really, really hard to say we have this one perfect toolkit that will just solve every single point on the spectrum. It just doesn't exist, right? When people say, like, I love Angular, I love Ember because they solve all my problems, but you definitely feel guilty if you're using them in a static page that just to display, like, you know, a list of people, right? And when you say, like, I love my vanilla JavaScript and try to build Gmail with that, you'll hate yourself, right? So it's important to pick the right tool for the job, like, and we all know that, but it's not that easy because, like, I think in the past, like, I haven't really found a framework that's kind of designed with this in mind. So that's more or less why I decided to make Vue that thing. So this is like the spectrum of frameworks that do from less to more. This is not about like good or bad. This is just like the design decisions they made from the beginning. Like some frameworks decide to cover more, make more decisions for you. Some of them decide to make fewer decisions for you and only solve a very dedicated set of problems. But things like React and Vue, they have all these supporting libraries that make them more capable, make them able to cover more use cases. So this is where I think the flexibility starts to shine because you know, web is very diverse. So scalability is not a one-way street. You can scale up. You also, in some cases, need to scale down, depending on what business are you in or what type of apps you're building. So this model, I like it. But about the optional support libraries, the thing about JavaScript Fatigue is React has this extremely vibrant community, which I actually quite admire. We take a lot of great ideas that's coming out of the React community, and I think it's a good thing that we have a community that's like that. But for some end users, it kind of leads to this fatigue of always trying to keep up with the latest new stuff coming out, and no one is authoritative enough to tell you like, hey, just use this, and you'll be good for like maybe 2 years. You don't have to second guess your choice every 2 months when the next hot CSS/JS library comes out. Yeah, so that's more or less the idea. We want to make some calls for you, but don't make it mandatory. I kind of divide the whole framework into layers like this. So at the core, it's declarative rendering. This is essentially I think this is the step where we move from jQuery to modern JavaScript frameworks. This is the thing that's shared across all the libraries out there. Any library that you use today essentially have to solve this problem because that's kind of the essential for any sort of UI development in general. And then component system solves the composability issue. Client-side routing and large-scale state management, these are kind of going into the larger scale single-page application realm. And then build systems, how do you have a build tool chain that allows you to leverage new features in JavaScript, do build time optimizations, and all that stuff. So Vue covers all that, and I'll quickly go through some of this. I got a lot of slides here, but I think we actually have a pretty packed schedule today, so I'm going to try to go fast. So declarative rendering. Obviously, we want the DOM to always be reflecting what our state is. So there needs to be some way to allow us to declaratively describe what this mapping between the DOM and our state is, right? So there's a lot of, so recently there was another, so I think we all, like if you've used any framework at all, you probably already know this, right? The thing about Vue and in particular and a lot of discussions are on the Hacker News thread recently is focused around templates versus JSX, which to me is just like the least important question. Because if we think about like this, like the mapping between DOM and state, both templates and JSX are just different forms of abstraction of this mapping, right? So if you understand this nature of what we're trying to do, you wouldn't really see these as that different. And in fact, both Vue templates and JSX compile down into vanilla JavaScript render functions. So in Vue, we also use a virtual DOM underneath. We compile the templates into render functions. And we also allow you to directly use JSX if you prefer JSX. So in Vue, you can actually write an application that has components with mixed rendering strategies. You can write your presentational components with templates because they are easier to think about styling. They're easier for you to work with designers. But you can also write these highly logical, complicated components using render functions, like dynamically mapping to different components, or like routing, transitions, and all that. Like even Vue's internal built-in components, like the router view or the transition components, are written with render functions because it's more appropriate to use render functions in those cases, and that's why we support them. So, right. So this is just rambling JavaScript in HTML, or HTML in JavaScript, or just JavaScript. They're all the same. They're all the same. So I already talked about these. I'll skip them. In Vue, we have this compilation pipeline that we parse our template into an AST, and we generate them into codegen into render functions. So in Vue, we have this. This is an app called Vue Template Explorer, and it allows you to see how Vue templates are compiled into JavaScript render functions. So in the Vue, so when you use Vue, there are a few different ways. Like you can just drop a single file in your browser. You can even write the templates right in the DOM, right? When you use that format, you're using the full build, which includes the template compiler in the Vue runtime. So the full compiler is like 8 kilobytes gzipped, which is pretty lightweight, so that we can actually ship in the browser without worrying too much about size. And if you're using a build pipeline like Webpack plus Vue Loader and the default Vue CLI setup, then all this template to render function compilation is performed at build time. So it's kind of like AOT in Angular. So we compile them beforehand, so when you ship them to the browser, it's already JavaScript. And yeah, this is just some internal details, like how we actually use the width as a hack when we're shipping the lighter weight version of the compiler, and we remove it when we're doing the full compilation at build time. So this is the bigger picture diagram. So each component has an associated render function. So this can be compiled from templates, or they can be directly handwritten. When they render, they would generate a virtual DOM tree. And during that render process, right? So because when you access properties on the Vue instance, and because all Vue data are reactive, this is something I will talk a little bit about later. So whenever a property on a Vue instance, a data property on a Vue instance is used or touched, the getter is invoked. So when the getter is invoked, the observation system actually knows that now this property on this object is a dependency of this specific component's render function, right? So this render process is a computation that can be rerun whenever one of its dependency changes. So this is the dependency collection system that we have in place, and every component has its own dependency collector called a watcher, right? The benefits of this is that each component knows exactly when it needs to re-render. So imagine you have a huge tree of components, and probably the biggest performance problem you'd run into in React is when you have a huge component tree and you set state from the root, right? That would cause every component in the tree to have to do a re-render unless you short circuit that somewhere with a shared component update or a pure component. But then that pure component kind of overshadows everything underneath it, and if you're using a React router like match component down there, it would not update. So you would run into some edge cases. But in Vue, the getter, so this dependency tracking system is very similar to MobX, but it's kind of implicit. You don't even need to think about it. It just kind of tracks everything for you and makes sure that only the components with changed dependencies actually re-renders. And it's optimal in most cases. There are some edge cases that we have to kind of bail a little bit, and like when you have parent-child relationships, like the parent passing child elements into the child. But in general, this is you get a optimized app out of the box. So you don't need to really think about this tree optimization. So there are still other areas of optimization you can think about, but like specifically this like component tree optimization problem is somewhat you don't need to think about it anymore. So using the virtual DOM also gives us the ability for server-side rendering, and this is the Hacker News app that's written using Vue 2.0 and uses server-side rendering, and it's a PWA. This is kind of like a kitchen sink app that we use to demonstrate like everything that we have in the ecosystem. And we also have native rendering via the Weex project. So Weex project is originally an internal project at Alibaba, which is the biggest e-commerce company in China, and they kind of morphed this into a public open source project, and they heavily use Weex in production. And they decided to make it public open source and eventually donate it to Apache Foundation. Unfortunately, their effort in internationalization documentation is not that great, but they do use it very, very heavily in their production sites. Like you can think of the Chinese version of Black Friday is almost all the traffic going through mobile is like on Weex. So it's rock solid underneath, but the English, the Western community side isn't doing that great compared to React Native. Component system. So we all know all the frameworks today are like components as the primitive, and I don't think we need to dig too much into that. So in Vue, the component parent and child relationship is very similar. Like parent would pass data down to the child via props, and the child can emit events back up to the parent so these events are custom Vue custom events. So they're just pure JavaScript events. Each Vue instance is also a event emitter. If you've used Node event emitter, you probably know what the API looks like. And the most important, like I would say the thing that a lot of people like about Vue is probably the single file Vue components. So this was in fact conceived somewhat inspired by a very, very early version there was an internal slide at Google before Polymer was even a thing that kind of mentioned this idea of separation of concern and how the whole idea about separating of concerns with languages is completely wrong, and that for a component, a unit of abstraction, the CSS, the JavaScript, and the associated template should be together, right? So that was kind of the philosophy behind single file components. It's collocation. In the past, in the very, very early days of web development, we're used to building things with template files, HTML files in a folder, JS in a folder, CSS in a folder. Like we probably still distribute the build files this way. But if you organize your source code this way, I guess most of you know how much a pain that is today, right? You would have extremely long files with intertwined logic, and trying to locate one thing in another is near impossible. So the more reasonable way is extract, kind of cut through these pieces and organize these things into these standalone units based on feature or abstraction or whatever. But essentially they are components. And a component can consist of template, script, and style, and even more things like GraphQL queries if you want to, right? So the good thing about collocation is now you don't have to do all the context jump when you are just dealing with this single component, because all you need about this component is here. And it's important that to also know that everything, the scope is very clear. All your JavaScript only affects the templates. All your styles with the scoped attributes are applied to this component only. And, and the whole thing is compiled into an ES module, so you know the exact dependency relationship. And if you don't want to import components, you can just use Webpack's context feature to just like global register them in batch. But I don't really recommend that. So collocation is awesome, and with Webpack, we wrote Vue Loader to leverage this. We can take the single file component as a source, a type of source, and we would parse and compile them. We have this Vue template compiler package that parses the single file Vue component into the 3 parts. Then we send each part further down the pipeline, templating to the Vue template compiler, JavaScript or TS into respective compilers, and the style part we send them through PostCSS, and we have a internal PostCSS plugin that handles the scoped CSS part. We also have first-class support for CSS modules because the style part is piped through CSS loader under the hood. So there's a lot of things about the single file components that we do for you under the hood because it's a source format. So we can do anything you can do at compilation time. You can use different preprocessors for each part. Like you can use Pug for your templates. You can write JSX in it if you want to. Any Babel plugin you want to use, you can use TypeScript. You can use Sass, Less, Stylus, or PostCSS, CSS Next, whatever you want. And it supports hot reload out of the box. If you use VCLI, everything is just hot reloadable. Yeah, so single file components is kind of the base unit for organizing the large Vue code base. And client-side routing, Vue ships with, we provide an official component-based router that maps your URLs, client-side URLs, into component tree structures. And internally, this is very similar. I think most mainstream routing solutions are more or less similar in this regard. We parse we allow you to write your URLs with parameters, with the colon syntax, and we parse them into regex, then match them against the actual URL. Then we extract the params and query so that you can actually use them in your application. So I wouldn't dig too much into it, but this is an official router, and it's proven to work with most of your applications. And large-scale state management, we have this official state management pattern called Vuex. It's obviously inspired by Flux and takes some cues from Redux as well. But it's the whole idea of not using Redux with Vue is because Vuex takes advantage of Vue's reactivity system. So if you've used Redux, you probably know, and most state management solutions in the React ecosystem prefers immutable data. But in Vue, the mutability is kind of the default, and mutability in Vue is kind of the basis where we gain this very accurate dependency tracking. And this is actually, in fact, where a lot of the optimization or the performance out of the box comes from. So we want to have a state management solution that's designed to take advantage of this. Although with Redux, you probably would get OK performance as well. And I know some people actually use it with Vue, but Vuex is there and it's official. So it works. We also have like sync bindings between the Vuex and the router, and they're designed to work together for server-side rendering as well. And our official server-side rendering guide covers how to use these together. So the point of having all these things under the same official umbrella is that we can, when we are working on the server-side rendering solution, we are able to sort of design these libraries so that instead of sometimes if you're using third-party libraries, you would have to resort to a lot of hacks or workarounds in order to make them work together for a high-level goal like server-side rendering. Okay, so build system and development experience. So we have an official CLI. The CLI is actually pretty simple. It's mostly just a scaffolding tool. It's not really like full service like Ember CLI or NG CLI. most of our stuff is like inside the template itself. So if you use the Webpack template, it comes with all these npm scripts, so you can do npm test, npm run build, npm serve, npm run dev to start your app. And it comes with Webpack view loader, hot reloading, all the stuff comes out, works out of the box. Most of the things you would expect, and we also allow you to create custom templates. So you can fork the official template and tweak it to your needs. So we have the PWA template, which is now an official template. But in the beginning, it was forked off the Webpack template, and Eddie Osmani worked on it and added features to it. Eventually, we pulled it back into the official organization, and now you can just scaffold the PWA app directly. But even without it, you can still do like Vue init, my GitHub username / my repository, my app. So it's pretty straightforward. And we also have an official Chrome DevTools extension, which allows you to inspect the component tree, obviously. And if you use Vuex, you would get time travel debugging out of the box. You can also, I think this is a screenshot of the older version, but in the latest version, you can also export the current Vuex state snapshot into a JSON file, and then import it elsewhere, so that you can sort of tell your coworker, like, hey, this is where I'm running into a problem. So DevTools, yes. And in terms of editor tooling, so right now, my recommendation is VSCode plus Vetur, Vetur, V-E-T-U-R. And Pine is going to talk more about it, but it was actually featured at Build this year, so pretty great. I think that's all I have for today. So, do we have time for questions?
Couple questions.
Sure.
Can you please comment on the status of Vue resources? Is that still considered as production ready, or is that already deprecated?
It is deprecated. We actually had a blog post on Medium officially retiring it. It was a third-party contribution, and we found that it kind of overlaps with like more like popular community solutions like AXOX, or you can use Super Agent, because the thing about AJAX request is that it's not really framework specific that much. Like you can use AXOX with React with Vue, or even in Angular if you want to. It's we don't really see the need for the HTTP client to be tightly coupled to our framework, and it's better to leverage something that the community already has and has more contributors, is more actively maintained. So our recommendation is use AXOX or Super Agent. Yeah.
One more question.
Hi. So for large companies, is this working? Okay.
Yeah.
So for large companies that are looking to potentially adapt a framework company-wide, what would you say to them if they're concerned about the relatively small number of developers and relatively small number of I guess, corporate backing behind Vue versus something like React or Angular?
So I think there are a few aspects about this. The first is, does fewer developers actually mean slower development? I don't think there's a direct correlation with that. If you look at the history, Vue has been around for like three years. We have a relatively slowly growing core team, but we've actually been able to come up with more new features in the past year than React in comparison. And the thing about React, like not necessarily a bad thing, because they have a lot of internal use cases. They have to be very, very careful about the addition of new features. They have to be extremely careful about changing things or coming up with things. And also, they don't really want to invest in things that they don't use themselves. So for example, React finally is getting streaming server-side rendering in 16, but Vue had that like when 2.0 came out last year. And we had like component level caching and auto critical CSS collection and all that stuff in our official server-side rendering solution, which a React core team probably doesn't even want to touch because it's not something they use internally at Facebook. So that's one aspect of it. The other is corporate backing. I mean, I don't really want to go into that, but like, you know, the patent stuff is something you might want to consider. Vue is completely MIT licensed. That's all I can say. And eventually, when we talk about, so in the past, a lot of people ask me that question. So the thing I usually tell them to do is go to GitHub and look at the, you know, the stats, the track record. So Vue has probably the smallest number of open bugs on GitHub in, you know, front-end frameworks of the same level. And we have, so I've been kind of in the transition period in the past month, but we have extremely prompt issue triaging and response time compared to, I know, like, you just look at the stats. So there's a website called Issue Stats, and it kind of, you know, do all these issue stats. And so what I want to get to is, like, you know, the size of the team or how many people are, you know, paid to work on it doesn't necessarily directly transform into like how fast this framework is going to evolve or how reliable it is. Like, it probably has a general implication, but in Vue's case, I think we've had a track record that's enough to prove to you that we are actually doing a very good job despite this difference. So.
This is the quickest question in the world, right?
I'm not sure if it's that quick, but what's the roadmap for the framework, and what's your policy on breaking changes?
So our breaking changes is, so currently, so after release 2.0, our policy essentially is we won't do breaking changes unless there's extremely important reasons to do so. So, which means as of right now, we don't see any reason. So there is one potential thing that we want to do in the future, but that's not really about changing API. It's really about the new features that's, you know, coming out in browsers, and we want to leverage ES6 proxies to improve the reactivity system. So currently there are a few small things due to the limitation of ES5 we cannot do. But if we ship a version of Vue that only supports the latest evergreen browsers, we can actually do quite a few improvements everywhere across the framework. So that's one potential thing that we'll do is we'll release a version of Vue that only works in browsers that support the latest ES features. But that one will be maintained in parallel with the current 2.x version, and both will retain API. They will have the same API. There will not be like API differences. The only thing is like browser compatibility.
Cool. All right. Thanks a lot, Evan.